Hey, what's up? Lunaticoin here speaking. For the English audience, let me just have a minute with my Spanish one. Este pod es un extracto del L163, con lo que si ya lo has escuchado, ya has escuchado este contenido, que será, a partir de ahora, únicamente en inglés. Back to English. This podcast is an excerpt from my Spanish show, from the episode 163. In it, I traveled in time to 1982 to explore what were the blinded signatures and the eCash system that David Chaum created. To come back then and explain what Fedimin is proposing and how it would work. After that, I have this interview with Kale, who really made me happy when he published Cashu, an eCash wallet and mint that allowed me to experience for the first time an eCash system after weeks of investigating about it. In this short podcast with Kale, I go directly to the main doubts I had around Cashu and Chaumian eCash systems. I ask him about how does the mint split sats in tokens, how does it choose its denomination, how does it deal with change, and how does it keep track of tokens that has never seen. These and all my Spanish shows are sponsored by 4 amazing Bitcoin companies that share my same values. Hodl, a peer-to-peer web market to buy and sell Bitcoin. Bitrefill, the place to buy everything through gift cards using Bitcoin. Brains, the good guys of Bitcoin mining where you can optimize ASIC miners and much more. And Lend by Hodl, the peer-to-peer web market to borrow and lend using Bitcoin as collateral. Without them and my Patreons, this show wouldn't be possible. Thank you for that. And now, let's learn the best details about Cashu with Kale. Good morning, Kale.
Hey Luna, what's up?
Here, very happy to be talking with you because I asked you yesterday, like, hey, I would love to chat a little bit about Cashu, and we managed to arrange it very fast. So thank you for that. And also thank you for creating Cashu, because I was really looking to experience an eCash system, and the Fedimin people was saying that no, until the end of September, nothing, and you will have to wait, no? So Cashu really made my week. Thank you for that.
Yeah, thanks, man. So I should also mention upfront that obviously Cashu is not a one-man show. There are a couple of people involved, and it's based on previous work. I want to mention here the original scheme by Wagner from the Cypherpunk mailing list. It goes back to the old days. Ruben Thompson picked out the equations and the blinding scheme with elliptic curves, and Fyro, which is a NIM, implemented basically the equations that Ruben dug out there, and I was the one who implemented it. So it's basically a chain of people who were interested in it, and here we are.
Why did you decide to sit down and code Cashu?
Yeah, first of all, I discovered the scheme of Ruben and Fyro a couple months ago, and I thought it was super interesting because I thought, well, there's the backbones of the crypto is there in Python. I'm a programmer, I'm interested in it, but also I'm working on a couple of other Bitcoin custody solutions, and generally speaking, Chaumian eCash is the, let's say, canonical way of making custody more private. So that is the original motivation, basically to provide a way to build custodial Bitcoin systems where the custodian doesn't know who you are, how much you have, with whom you're interacting with. And so I sat down and coded it down in a mad session of a week or so. And yeah, here we are.
Yeah, I loved your disclaimer at the beginning saying like, hey, I'm not a cryptographer. This is my like kind of a weekend project and it's buggy and it's probably broken. Be careful, no? But the truth is that I install it, I try it. I tried already when you had, when you were able to, to send out to pay Lightning invoices. No, at the beginning it was only possible to send in but not send out. So yeah, it worked for me. I was part of the torch and very happy for that. And being like the first eCash system that I am able to play with, I have some questions focused in the eCash tokens denomination. I'm aware of how blind signature system works inside an eCash payment system, but my doubts with it is how big or how small do you create those tokens? Because we're here talking about a coin-based system. We are not an account-based system. eCash systems are based on coins like Bitcoin. So it is very important for the privacy that it can provide that you have a lot of the same type of coins. So when somebody mints some satoshis inside Cashu, how does Cashu manage it? How does it choose the denomination of the tokens?
Yeah, first of all, that's a great way of summarizing it. Just to recap, maybe the reason why there are fixed denominations in a cash in an eCash system is because you want to increase the anonymity set, basically, of the coins. So you can imagine that a Chaumian mint has different keys for each denomination. Let's say for 2 satoshis, 4 satoshis, 8 satoshis, all of them will be signed with a special secret private key, and that is to increase your anonymity. So I guess it is clear from that let's say if you would have a coin that is 348,057 satoshis and you move that one from A to B, it would be pretty easy to figure out who paid whom. Basically, that's the reason why we have to limit the set of coins, of coin denominations. So then this opens just a very generic design question. How do you want to split the tokens in different denominations? And there are different ways of doing it. One way would be just doing it the way that regular fiat cash works, right? So you would have a $1 coin, $2, $5 bill, $10 bill, 20, etc. So these are the denominations that we know from fiat system. And but you can choose any arbitrary splitting. In Cashu, we have chosen just very natural way of splitting into powers of 2. So in Cashu, tokens are 1 satoshi, 2, 4, 8, 16, 32, etc. And the way this is handled is pretty basic. So you can imagine that a client will ask the mint, "Hey, can I have 150 satoshis, please?" And the client itself and the mint have the same function to split this number into powers of 2 to the n. So the way it's done is very simple. You can imagine any number represented as a binary string, so ones and zeros. And for a binary string, you can decompose any binary string as a sum of 2 to the power of n's, depending on whether there's a 1 or a 0 in each place of this number. So that's how tokens are split. The client knows how to split before minting. The server knows exactly as well how to split this 150 satoshis. And let's say that would be then a sum of a 128 satoshi plus a, now I have to make it up because I didn't calculate, 16 satoshi, 4 satoshi, 1 satoshi or something. And then you end up with 150. That would make, for example, 4 coins to mint 150 satoshis. That's how the client and server communicate. They agree on it. Then the server creates these tokens, and then we have all these eCash, yada, 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 how it's then generated.
With such a granularity, because I didn't know that it was done with powers of 2, I don't know if the next question makes sense. But one of the struggles I had when I was studying David Chaum model was like, okay, so you have coins here, but what if you have to pay, let's say that you have 2 coins of 100 satoshis, no? What if you have to pay 150 satoshis? In Bitcoin, it's easy. You create 2 outputs, no? And one gets back to you is the change, and one is the payment. But what about here? Again, I don't know if with such amount of granularity you get to this kind of problems, but I suppose there can be the situation, no, that you have to pay something and you don't have the exact amount of coins to pay. How does Cashu deal with this kind of situation?
Yeah, so that's a very common situation. And with Cashu, you don't have any change, basically. You pay exactly the amount that is requested. So if you have in your wallet a certain set of coins that is 2 to the power of n, but now you want to pay something, 150 satoshis, you said. What you would do is then take a set of coins that you already own and send it to the mint and ask them to split it in such a way that you get exactly 150 satoshi back in one set and then the rest. So you basically send more or exactly the number that you want to send to the mint and say, destroy these tokens and split them in such a way that I can pay 150 satoshis to my peer. So basically you get exactly what you want to pay to the peer. That, of course, means that you have to communicate with the mint at least once to get the exact split that you need. There's also ways to probably improve this so that you don't have to talk to the mint. I mean, in the most simple case, you would. But you could also imagine that if you have Alice and Carol, being Alice pays Carol some amount, you could also imagine that Alice overpays Carol and Carol pays back the change to Alice if they have the exact coins that would match exactly the payment that they would do. In this case, obviously, this would rely on trust, but in general, it's possible that you can have a back and forth exchange of tokens between two parties such that the change can be sent back. But just to summarize again, you don't usually pay change. You split the coins before you pay exactly to the amount that you want to pay.
What if you have the exact amount of coins that you need to pay? In Cashu, do you always have to go to the mint first, nevertheless? Or you are able to pay to Carol and then Carol checks with the Cashu mint if those coins are valid?
Right now in the implementation, you talk to the mint every time you make a payment, but that is not necessarily the case. So just in general, you would do that every time, but you could also check beforehand whether it's necessary or not. You don't lose anything except for having one round of communication with the mint because you get new coins immediately from the mint that then you can forward back to Carol. But in general, you wouldn't have to do that. If you have the exact amount of coins in your wallet right now, then you would just hand them over to Carol, and then Carol would redeem them with the mint such that the payment is complete.
And then I have one last question that I hope that I will be able to explain it with my broken English. But when you mint a coin beforehand, to make those coins blinded to the mint, you create your tokens, no? And then you kind of encrypt them, no? And then you send them to the mint encrypted, no? And then you ask to the mint, put value in those tokens because I want to redeem that value that I'm sending you, the satoshis, but put those satoshis in those encrypted strings. Then they put value, so the mint notes those strings, puts value in it and signs them. And then it sends you back the signatures of those encrypted coins. Okay, then you receive that signature, you unencrypt it somehow, okay? And then you have a new pair that is valid, but both of those pairs, the signature and the string, the mint has never seen, never in his life. That's why it's you are able to later on pay with that string, but the mint doesn't know that it was yours. Okay, we're here. So then my doubt here, or my question comes, let's say that the mint created 10 coins of 100 satoshis, and then they send it to the client through this system. Then Carol, let's imagine that you give them to Carol and not to the mint. You give them to Carol, and then Carol checks with the mint if those, if let's say these 2 coins of 100 satoshis, if they are valid. So the mint has never seen those strings and those signatures, but is able to check that the signature is valid. And then my question is, what information does the mint keep in order to not make double spending possible? So because I suppose that they note this new string and signature that they just received, but how do they match it with the ones that they minted? Do they match the size of the coins? Like, for example, we minted 10 coins of 100 satoshis and now I receive 2 coins of 100 satoshis. So I can only receive 8 more coins of 100 satoshis? Or how does it match?
That is an excellent question, and that was also one of the points that I struggled initially just to wrap my head around it. But it's important to remember, so the mint never knows, even if you redeem the coins later, whether they know whether they signed these coins, but they cannot associate it to the signature before that they made. So even if you redeem them later, they don't know who they correspond to. So basically what the mint, there's only one thing in a minimal setup. There's only one thing that the mint needs to keep track of, and that is the secret that Alice, the one that minted the coins initially, the secret that Alice generated. So as you said, Alice generates a secret, blinds it, and sends it to the mint. And then the mint doesn't need to remember anything. In a stateless case, the mint just signs it off and sends it back to Alice. Doesn't need to remember anything. But now, when Alice wants to redeem, when Carol wants to redeem these coins, she needs to present the secret that Alice generated. And that's communicated to the mint. The mint looks at the secret and says, great, I haven't seen that secret yet. There's no way that the mint can associate that secret to the signature that it provided before. But it hasn't seen the secret yet and puts it in a database in a list of secrets. And that's the only thing that a mint needs to keep in the minimal case is a list of secrets. So the way a mint knows whether there is a double spending attempt, yes or no, is just by looking into this table of seen secrets. If you provide the same secret again, then the mint will just say, no, this is a double spending attack. But if it never has seen the secret before and can verify, yes, I signed this thing, then it just says, okay, this is a valid token, I'll give you new ones, and adds the secret to its database.
But then how does it match the amount minted with the amount redeemed? You know what I mean? Because you are receiving coins, no? That that Carol is telling you, yeah, this is 200 sats, no? In 2 coins. But you have to somehow internally match the size of the coins that you minted at the beginning with the size of the coins that you never saw before, but that you can prove they are signed by you and that you are getting redeemed later on. Is that how it would work? Because this is the point where I'm struggling to find the connection.
Okay, so now I get your question, and this is how it works. So the mint doesn't have to trust the client to provide the correct value. The way this is solved is when we go back to the beginning of our conversation, we said that the number of amounts is limited. That implicitly means that for each amount, so for 2 Satoshis, 4 Satoshis, 8 Satoshis, the server has a special key. It generates a distinct private key for all amounts that it can mint. So when now the client comes back and says, look, here I want to take out these 16 Satoshis, it tells to the server basically, this is 16 Satoshis, please use that private key that you have stored, that I don't know, to verify that you signed this message. So there is no way basically to pretend as if you got more than before, because there's a distinct private key for each amount that you want to redeem. That's how it works.
That's amazing. That's amazing. I'm smiling because it's a great solution. Yeah, of course, you then check which signature signed that blinded token, no, when it was blinded, and then you see, okay, it was signed with the 8 Satoshis token, as a private key. So then it has to be a token of 8 sats. I'm not gonna give you anything else, no.
And if you would provide the server the signature that was originally signed by the 8 Satoshi key, but you say this is 16 Satoshis worth, the server will just use the 16 Satoshi key and then check the signature and say, no, this is not a valid signature. It doesn't compute with the 16 Satoshi key that I've stored and generated before.
And then it matches knowing which token is what, or the value of each token. Then you match amounts, no? If you minted 100 tokens of this denomination, the server is only gonna redeem 100 tokens of this denomination. If something else, if it comes 101 token signed by me, there is a big problem in the server because something failed, no?
Exactly. The server will just simply refuse to cooperate with you, and you won't be able to redeem these tokens.
This is great. And I told you at the beginning that you made my day when you, or my week or whatever, when you created in collaboration with these other people you mentioned, Cashu. Now making me understand this, it relieves me a lot, because at some point when I was studying how the David's Chaum eCash system, how it worked, I was about to write him an email or something and say, hey, please, can you explain me this? Because it's really bugging me. But yeah, before finishing, I just wanted to ask you what next. I have seen some update that you yesterday, I think you published on Cashu. What's next on the roadmap of it?
So the idea of Cashu itself, and generally speaking, some of the projects, especially LNbits that I'm involved in, is to decentralize the custodian. That's our mission. We want to make it as easy as possible to be a custodian for your local community, for your family, and so on. So the next thing that we're working on is to implement Cashu into LNbits itself, so you can become a mint with a single click, basically. And also, we're building a web client for Cashu. So right now, everything is in Python. The mint is in Python. The client is in Python. But we're trying to keep Cashu as simple as possible, such that it is easy to implement alternative clients for it. So you can view the Python client as something like reference client, and the JavaScript client will then be able to run in a browser that you will be able to use, for example, in conjunction with LNbits, such that you can have these blinded privacy-preserving tokens in a LNbits server that someone else runs. So what we're doing right now is also one of the goals of Cashu, because Chaumin eCash systems can be complicated, and we're trying to keep it as simple as possible, such that it is easy to understand and build on top of it. So my goal is to make Cashu a library, more a library than a client or a mint that you run, such that if it's a library, I believe it can be incorporated in existing custodial solutions and just simply improve many custodial systems that we have out there by increasing the privacy for the users.
Sounds great, Kale. Thank you for this fast interview that we managed to make, and it was great to talk with you again.
Thanks for having me, Luna, and see you around.